Hello, welcome to Programming Rainbow. In this video, we will continue on the series of the Beginner's Guide to SDL2 in the Odin language. So if you're just starting out with this video, this is video number 3. There are 2 videos before it. And if you want to follow along, you can go to github.com, Programming Rainbow, Beginner's Guide to SDL2 in Odin. You can clone that repository and then move inside of it. And since this is the 3rd video, you can delete this main.odin file, which is the code for the final video, and you can go inside the folder for the 2nd video, and you can copy that into the top level directory, and you'll be at where we are in this video. Okay, so the last video is video number 2. Let me just show you where we ended off with. We have created a window that we can open and that we can close either by telling it to close or by pressing escape. And it just shows a black screen. Okay, and at any point I can just press escape and it closes. So in this video, we are going to bring in a new module, a part of SDL2, which is the image module. And we will be using that. We'll initialize it, and then we will be able to load a PNG image as a texture and display it on the screen. So this is part of SDL2, but it's like an add-on module. So it's going to be SDL2/image. Okay, now if I go into here, into the vendor, I'm going to add a new import. And I'm going to call this IMG. It's going to be vendor : SDL2/image. Okay, so that's going to give us access to all the goodness of the images module for SDL2, and it'll all be under the IMG. Okay, so the very first thing we need to do is initialize this one. Just like we initialized SDL, we need to initialize this. So again, I'm going to be showing you the actual C SDL2 documentation because it's a little bit better, but it's pretty straightforward. It's image init, and for us this is going to be small img period init, and it takes some flags and it returns flags. So the int that it's returning is the flags that are ORed together, and when they say OR, they mean a binary OR. And let's see if we can see these flags here. So these flags down here, they have a number under the hood, a bit that is turned on or off. And if you want to set multiple flags, you can put them together and you can use an OR operator. And I'll show it to you in a second here. And so what I'm going to do is I'm going to set up a constant that's holding however many flags I want turned on. And what I'm going to do is I'm going to put that constant in here to tell image init what flags I want turned on. It's going to output what was actually turned on, and then I'm going to check that against to see if what came on the output was what I intended to be turned on. So we're going to kind of see this in practice. It might be a little bit weird because we're going to be using binary ORs and binary ANDs, stuff like that, but let's just check it out. So this is very simple. It's just the init for image and the flags. And the flag that I want to use is going to be called image init PNG. Let's just see what it looks like with PNG and JPEG. So I'm going to go to where SDL flags were. I'm going to add a new flag. I'm going to call this image flags. And this is IMG init. And we see PNG is the one I want. But here's the thing. If I wanted to add 2, I could do this. I could do an OR operator, binary OR. So you may know a logical OR like this with 2 pipes. But if I just put a single one, I could do IMG init, say JPEG. And I could ask it to turn both of these on. And this is going to work on pretty much all the flags, I think. It might not be every single one, but definitely works on this one. Let's see if it complains about this. Okay, so the reason why I'm putting both of these here, so I have them under one name, whatever the answer of this is. So there's some numbers under the hood, and they're being bitwise ORed together. So I'll give you an example here. Say PNG was 3 and JPEG was 5, right? If I was to just add those together, I would get 8. But imagine in binary, let's just say that's 4 of them here. In binary, this would be like that for 3, right? And then 5 would be, whoops, like that. Okay? Now, if I ORed these together, my answer is going to be, and this is not the same. This is, the answer to this is 7, not 8. It's 1, 2, 4, 8. Yeah. This is 7 right here. So this is ORed. ORed says if this or this is 1, this is 1. If 0 or 1 is 1, this is 1. If 1 or 0 is 1, if either one of them are 1, it's 1. If either one of these are 1, it's 1, and neither one of them are. So this is a binary OR operation. Now I can use a binary AND operation to mask out the answer that I want. So imagine this. Imagine I ask it to turn on this bit. This is the thing that is PNG, say. PNG right there. And I ran it into the init, and the answer I get back is like, this is the answer I get back, okay? And I only care about if PNG is turned on. Let's say this was JPEG, and this is PNG, and this is TIFF. I don't care about all that. All I want to know is, was PNG turned on? So how can I check that? If I check this binary number against this binary number, they're not the same. But if I were to do an AND operation, which is a single ampersand, if I do an AND, 0 and 1, they both have to be true. 0 and 1. Well, let's start over here because it's easier for me. 0 and 1 is 0. 1 and 1 is 1. 0 and 0 is 0. 0 and 1 is 0. Okay? So if I get this output, and then I use the original thing I wanted as a mask, this is masking it, I'm going to get the answer. Now what if it did this? What if every bit was turned on except the one I wanted? My answer would be this. Now I can compare this to this and know that PNG was not turned on. Okay, so I hope that makes sense. We'll see it right here. Let's just do it and see what it looks like. So this is the OR operation. So whatever bits are turned on to make this thing, plus whatever bits are turned on. It's not adding them together. It's just saying if either one of the bits is turned on, it's on now. So it's not additive. It's like combining them. And the AND one is masking. Okay, so I'm going to hold it here. What I'm going to do is I'm going to go down to initialize, and I'm not going to put it at the bottom. I want all the kind of modules initialized up here. So I'm going to do it up here. And I know it's img init, and I know what I want to pass into it is the image flags. Okay, but how can we check if this is correct or not? Well, what I want to do is capture the answer to this. So I'm going to call it image flags, or maybe flag, I don't know. Doesn't matter. So I'm going to capture the output of this. So whatever this spits out is what the flags were that it actually. So this is what I want to turn on, but it may turn on extra things, or some of the things I want to turn on may have not been turned on. So this is going to be my output flags that this happened. So now I can check that, the very first thing I want to do is mask it out to the answer I want. Because let's say this had just 1 bit turned on and this had 10 bits turned on. Well, I only care about the 1 bit. So the way I can mask this is with the original. It. Okay. I'm going to say if, and first thing I'm going to do is mask it out so then I can compare it. I need to mask it first before I compare it. So I know this is what I want to see, but I can't check it directly with this. I need to mask this first to get the answer. So image, init, and I'm going to use the single bitwise AND operator to mask it. Okay, so now this is going to give me the answer that I want to check up against this now. So I'm going to say, if it's not equal, something went wrong. Okay, so I hope that makes sense. Not equal to image flags. So I'm using this to mask out, because this could have extra answers in it that I don't care about. I only care about the things I want to be turned on. And then once I have that answer, then I can actually check, are those two equal now? So again, if I wanted 100, that's what I want, and I get back 1001, okay? So this is what this is right here, is here. This right here is this is coming back. So this would be my image flags, and this would be my image init. So I'm going to mask them to get the answer that I want, which would be 1001. So that is the answer that I'm getting right here. Sorry, this is not right. It's right there. So that's the answer I'm getting here, and I'm checking it against this, which is this top guy again, to see, does it not equal the original answer? Okay, and we can check it. If our answer back was this, then this would be the masked answer, because there's no bits that are in both. And then I'm checking this against this, and I can see that they do not equal, and something bad happened. Okay, so that is how we're checking to see if this worked or not. And if it didn't work, I'm going to do the bailout and the message that I've been doing already. But I'm going to say initializing SDL2 image. That's the name of this module. And since this is the IMG, I can use the IMG error. But realistically, under the hood, this IMG error is actually pointing at SDL error. These are actually the same thing, but there are each module has its own error message. So I use the name, but I believe if you look at the source code for SDL, the header files, this is just pointing directly at that. They're the same thing, but I'm going to try to use the correct one. Okay, so this should initialize the image module for us. Okay, and let's just see if this complains or not real first. Okay, didn't complain. And then what happens if we just change this to equals? So there is a check happening there. And let's see. So what I'm going to do up here, I'm just up here, since we've put two things in here, I actually don't need these two, but I'm just going to kind of print this out. Okay. I'm not going to print it here. I'll just do it in here. Oh yeah, I'm making all kinds of mistakes now. Okay, there we go. So I just want to kind of print out what this is right now. Oh, it actually tells me that both JPEG and PNG are on. Let's see what happens when I... Because they could be doing something totally different than what C is doing. Yeah. I need to move it after. I don't know why this is changed. I'm just curious to see what this will print out as. Okay. Still does the same. What if I mask out, say, PNG? Because this is different than what it would look like. It would just be a number in C. So this is interesting to me. So let's just do the PNG and see if we only get PNG as the answer. There we go. Yeah. And it gave us the PNG only as an answer. So that is really cool the way this works. In C, it would just actually be a binary number. But yeah. So we're running this initializer with the flags we want, and we're specifying the flags above. We're capturing what flags actually happened. We're masking out any we don't care about. And then we're checking the equality against what we originally wanted. And if it's not true, we are printing an error message and we're bailing out. Okay, so let's go to the next. We're going to load an image now. So the reason why we're doing this is because SDL itself only loads bitmap images, and we want to load PNG images. So the image module gives us a way to load PNG images directly to textures, to hardware accelerated textures. So we're done with that one. So the way that we load a texture, we're not going to load it as a surface. We're going to load it directly as a accelerated texture that uses the render. So the way that we do that is we need to pass the render in, and we also need the file where the image is, and it's going to return us a texture, a pointer to a texture. Okay. It's pretty straightforward, and we're just going to check the pointer if it's nil. If it's nil, something went wrong. So up here at the top, we do need to make, we're going to capture it here. So let's call it background. And it is a pointer. So this will be XDL texture. Oops, I'm going to put a at the back. Okay, so just like the window and the render, this is a texture. It's with the caret here, it's a pointer. The background is a pointer to a texture. And what I'm going to do is I'm not going to put this in initialize. Initialize this thing. I'm going to create a new procedure, and I'm going to call it load media. This is where I'll load images and music and fonts, things like that. And this is going to be the exact same thing. We have the G, and it's a pointer to a game struct. And this is going to return a Boolean, just like we have up here in the initialize. So if anything goes wrong, we can bail out early with a negative. So our default is return true. Okay, so it's going to be in here. So the way we use that function there is it's going to be img load texture. Yeah, it's load texture right here. So we need the render, and then we need a string to the file. So the render is g.render, and the image that we're going to load is over here in images folder or directory, and it's called background.png. So that's the one this is a relative path, so I'm just going to put images as the relative path, and the background.png. Now this is a PNG image. Everything that I'm loading is going to be PNG. So I was just showing you up here with this, or we don't need this because I'm not loading any JPEGs. But that's why I put these flags up here, or so that you could do that. You could give different options. You could give different window options. You could initialize, say just the audio, not everything, the audio or whatever you wanted to do. That's set up there like that. Okay, so right here, we are capturing this. So this is returning a pointer to a texture, yeah? So we're capturing it in G background. And then we need to test it. So I'm going to test it just like I tested the render up here. I'm going to yank that, put it down here. And we want to know if background is nil. And if it is nil, this is coming from image. So I'm going to change this SDL error to image error. And it's going to be error loading texture. Okay, error loading texture, and then we're returning false. So when we return false, something bad had happened. Okay, so we haven't called this yet. So just like right here, the way that we called initialize with game, and then if it's failed, we are changing the exit status and we're returning. I'm going to do the very same thing. So I'm just going to yank this. So we're first initializing, and then we're loading media, and then we're running the game. The running of the game, we're not checking if anything is errored or not, but in initialize and loading of the media, it's very important that nothing went wrong there. So this is going to be load media, and we're checking if this is not true. If it's not true, something bad happened, and we're changing our exit and we're bailing out. And we're passing in game as a pointer. Okay, so that should be able to call load media just fine. So we're initializing the image, and then we are loading an image. But the problem is we need to clean up after ourselves. So how can we unload this image? So it's not in the image module, it's in the actual just normal SDL module. So the image module helps us load PNG images. SDL can load bitmap images and convert them to textures, but it can't directly load PNG. So textures already exist in SDL in the normal SDL module. So this is SDL destroy texture, and all it does, it doesn't return anything, is it just takes in the pointer and it unloads the memory, whatever was allocated to it. So we're going to use this, and I can just copy the C version and just convert it very easily. So I'm going to go up to our cleanup. And again, everything's happening in reverse order. So since this is an image thing, I'm going to kind of separate it out. Since this was initialization, I'm going to put it here, and this is the C version, so right here we need to change our SDL to what we used in the dot. And right here, this is going to be our background. So G dot background, okay? But there's still a couple problems with this. We want to make sure that background is actually a populated pointer. It's not a nil pointer. So we want to do a nil check on it first. If is not nil, then we will run this code. And that's going to work for that. The other thing I want to do is shut down the image module. Right down here. So I'm kind of doing this in reverse order. I'm unloading the image. I'm destroying the renderer, destroying the window, and then I'm going to shut down the systems. So this will be img quit. So we haven't displayed anything, but now we're loading and we're unloading this image correctly, and we're unloading the module as well. So let's look at how we can display this. So we use SDL render copy, and this is what's going to draw it to the renderer. So we need a pointer to the renderer, we need a pointer to the texture, and then we need the address of a rect for our source and an address of the rect for our destination. So the source is how big. Let me show you an image real quick. Okay, so see this image right here. So my whole screen is here, right? But if this was the image that I'm talking about, not the whole screen, my source rectangle for this image, if I put nil here, if I told it to take the whole thing, it would be from here to here down here. It would be this would be the whole image, right? But what if I just wanted 50 pixels by 50 pixels? And the top left corner, I would take 50 pixels down by 50. I'd just take this amount of the image. So that's my source rectangle. My source rectangle can be part of this. If this is my image, it can be part of this. It could be in the middle because there's an X, a Y, and a width and a height. So I could move the rectangle around here and just take part of it. I could just take the O from Odin. Or I could take the whole thing. Then my destination rectangle is where I want to draw this on the screen. What if I want to draw it up here at the top? That would be my destination rectangle. I would draw it up here, and my Y coordinate for my destination wouldn't be very big. So the thing I'm going to do with the background image is I'm going to use nil and nil. If I use nil for the source, it takes the entire source. And if I use nil for the destination, it's going to stretch that image to take up the whole screen. It would fill up the entire screen like this. Okay? But it's my background image, so I already want it to take up the whole screen anyway. So that's what I'm going to do. I'm going to use nil and nil. So for the source, and then this is a source rect and a destination rect. And it says null here because this is the C version. But if it's null, it uses the entire texture. And if it's null here, it's going to stretch to the entire renderer, to the however big the renderer is. And because of this particular image needing to take up the whole screen anyway, I'm going to use nil for both of these. So we have a render, we have a texture, and we have two rectangles, the source and the destination. They're both going to be nil. Okay, so, and I'm going to ignore any errors out of this because during the game loop, I'm not checking errors. I'm going to check errors when I'm loading stuff, when I'm initializing stuff, but not when I'm displaying stuff really fast. I'm not going to check errors there. So this is render copy right here. So right between the render clear and render present. So this one's clearing the render, and this one's actually showing people what was on the render. So between these two, I'm going to draw stuff to the render. So it's going to be SDL dot and render copy. So the first thing we need is the render, G dot render. The next thing we need is the image, which is G dot background. And then we have the destination rect and the source rect, and both of them are going to be nil. And this is returning a number to say if it failed or not. I'm not checking it. I'm not even returning anything from this procedure at all. So nothing, I'm not checking anything in this running loop. Okay, so we should have this loaded and showing an image. That's hopefully it'll work that way. Okay. Now you may be asking, why is Odin not stretched? Why isn't the blue all the way stretched up here and this blue all the way stretched down here and this blue? It's because this image is actually, it is stretched. This is a transparent part of the image. The Odin is not taking up the entire image. It's actually transparent. Let's see if I can. That's the image. So it is being stretched. The image is 800 by 600 and the window is 800 by 600. So when I say stretched, it's actually not being stretched at all. It's 1-to-1. But this is a transparency right here. So it's blue with a transparent background. And our render happens to be black, so right now it's displaying black. That's why it's displaying black. If we change the color of the render, it will change the color of this bit that's behind the blue. Okay, so let's kind of cover what we've done here. We have set a new image flag up here that holds our PNG. This is specifically because I'm only loading PNG images, not JPEG images. That's why I've chosen this. And then in our initialization, I'm calling image.init with that flag that we set above. I'm capturing the output flags. And then the output flag, I'm masking it against my original with the single bitwise AND. And then the answer to that, I am checking the equality. If it doesn't equal the original intended flag, something went wrong. And I'm just printing out an error message to standard error, and then I'm returning false. So since that's loaded, I am loading a background with image load texture, and it needs the render, and it needs the location of the image. It's holding it in this pointer. We're going to check that pointer to see if it's nil. If it's nil, that means this failed. This function, if it fails, it does not populate this. So this will still be a nil pointer. Okay, so we can try that. Let's spell this wrong. And we'll see the error message that I put, and then we'll see the actual error message. There we go. So error loading texture, that's my part of the error message. Now the second part is coming from image error. And it says couldn't load image background PN because it's spelled wrong. Okay, we'll run it again, and it looks good now. So this is loading our image. This is all about just checking the error. And up here, we're unloading with destroy texture, but we're first making sure the pointer is valid before we do that. We don't want to free a pointer that is already free. And then we are at the bottom right before shutting down SDL. We're going to shut down the image module. Okay, so now that we have the image loaded, we put it between the clear render and the present render. This is where all our drawing happens, and it's going to draw back to front. So the background is going to be the most back thing. Anything on top of it will be underneath it, and will be drawn on top of it. And this image, because I wanted to take up the whole screen, has a source rectangle of nil and a destination rectangle of nil. We will be using rectangles later with the fonts that were load as a texture, and then the sprite that we load as a texture. We will see that, but for right now, it's just nil and nil for the background. And we have this exact same thing going on that we did for Initialize. For load media, we're doing the same thing. We initialize first, make sure no errors occurred, and then we load, make sure no errors occurred, okay? So I think that's going to be about everything. Whoops. Why did I just do that? Okay. So that's, We did forget to change up here in the last video. It should have been 2 close window, and it was actually 1 open window. This one is going to be 3, and it's going to just be background. Put a capital B on it. There we go. And that's going to be the title. So when we run this up here, it says 3 background. Wherever your title is on your system, that's what it's going to say as well. Okay. Hope you enjoyed it, and have a good day. Bye.